Hello everyone, today in this video we are going to talk about vectors. So after watching this video you should be able to represent vectors by picture. State triangle law of vector addition. Find the dot product of two vectors. So the vectors are those physical quantities which has both magnitude and direction, and they also obey law of vector addition. To represent a vector we make use of a line with arrowhead, and this side is called tail and this side is called head. The length of the line gives the magnitude of the vector and the arrowhead gives the direction of the vector. For example, this is a vector A and it is pointing towards this direction, and vector B is the another vector in other direction, and the magnitude of B is greater than the magnitude of A. And vector C is another vector having magnitude greater than A and B, and the direction of C is in this direction. Equal vectors are two vectors having same magnitude and same direction. Out here you can see vector A and vector B, they are along same direction and their magnitudes are also equal. That means A vector is equal to B vector. And negative vector means vector having same magnitudes but their directions are opposite. Out here you can see A and B are having equal magnitude but they are directed in opposite direction. So I can write B is equal to minus A, that is the negative of A. So we can say B vector is the negative of A vector. So when you take this A this side, it will become A plus B is equal to 0. So when we see A plus B is equal to 0, then we have to say A and B are negative vectors to each other. Now we will represent the vector addition by pictures. So this is vector A and the direction of A is towards the right, and we have another vector B and direction of B is same as direction of A. So I'll shift this vector A out here and I shift this vector B out here. So the length of the resultant will be the length of A plus length of B. So out here R is the resultant vector, and which is equal to sum of two vectors. Now let's do the subtraction of vector. So again we are taking two vectors A and B in the same direction. Now I'll reverse this vector B, so it will become negative B, and I'll shift this vector out here and I'll shift B out here. Now this part of vector A is cancelled by the vector B because it is in opposite direction. So resultant will be from here to here. So our resultant is A minus B. Now we will add two vectors having different directions. Now I'll shift this A down and I'll shift this B out here, so that tail of one vector and tip of another vector comes together. Then the resultant of these two vectors will be the vector starting from here ending at here. So this is the resultant vector, and this process of adding two vectors is called triangle law. And it states that if two vectors represent the two sides of a triangle, then the resultant of these two vectors will be represented by the third side of the triangle. But you have to take care that the tip and the tail of two vectors should come together. So this is called a triangle law of vector addition. So out here you can see tip and toe of two vectors are together. That means this is the resultant of these two vectors. But out here the tip and toe is not coming together, so this is not the triangle law. Now subtraction of two vectors. Again I'll take the A down out here, I'll take the B out here. Now I want to subtract, so I want the negative of B, so I'll just change the direction of B. Now again I can see these are the two sides of triangle and tip and toe of two vectors are coming together. That means third side will give me the resultant vector. So this is R is equal to A plus of minus B, so it will come A minus B. So this represents the resultant vector. Now we will do multiplication of two vectors. So in vectors there are two types of multiplication. One we call it dot product, in which we multiply two vectors and we get scalars. And second product is cross product, where we multiply two vectors and we get the product to be vectors. So now let's see what happens in dot product. So we have two vectors, vector A and vector B, and the small angle between them is theta. So we can consider this angle also. This I call it big angle, and this is the smaller angle between A and B. So when I say dot product of A and B, I will write A dot B. We should not use multiplication symbol out here. So the dot product of two vector is equal to product of magnitude of A and B and the cosine of the smaller angle between them. If you want to find the dot product of A and B, then you should multiply magnitude of A, magnitude of B, and cos of small angle between them. And for magnitude we can just write A and B without vector sign. So A dot B is AB cos theta, and one of the example of dot product is work done. So to find the work done, we multiply force and displacement. Force is a vector, displacement is also a vector, but work done is a scalar. So by multiplying two vectors we are getting scalar. So this is the final formula. A dot B is equal to AB cos theta. Now we will find the product of I dot I. I cap means a unit vector along x-axis, and unit vector means a vector with magnitude 1. So now I dot I, using this formula I can write magnitude of I into magnitude of I into cos theta, and magnitude of I is 1 because I cap is a unit vector, and out here theta is 0 degree because angle between x-axis and x-axis is 0 degree, because we are finding the angle between I, and I has one direction, that is towards the positive x-axis. So I dot I is, now I'll put the value 1 into cos 0 degree, cos 0 is 1, so I dot I is 1. Next we will find I dot j. So this is the formula again. So magnitude of I and j is 1 because they are unit vectors, and the angle between I and j, that means x-axis and y-axis, is 90 degree. So now I'll put the value 1 into cos 90, and cos 90 is 0, so I dot j is 0. So similarly, if I find I dot k, so the angle between I and k, x-axis and z-axis, is also 90 degree. For this also dot product will be 0. If you consider I, j and k, we have proved that I dot I was 1. So I dot j is 0, I dot k is 0. Again j dot I, the angle between them is 90 degree, so it will come as 0. So j dot j, there will be cos 0 degree, that time I will get 1, and out here also you will get 0. Similarly k dot k will be 1, and k dot I and k dot j will be 0 because the angle between them is 90 degree and cos 90 is 0. So this is the very important table which we will be using to multiply two vectors. So if you multiply the same thing you will get 1, and if you multiply two different things you will get 0. Now let's see the general formula to multiply two vectors. So out here we have two vectors, a vector and b vector. Will multiply them, and we know this table. Now when I multiply these two, I have to multiply this and this first. So ax into bx, I into I is 1, so I'll write this term. So when I multiply ax into by, there will be I into j, but I into j is 0, so I'll not write this term. Ax into bz, again I have I and k, so it will be 0, so I'll not write this. So now I'll multiply this with this term. So ay into bx into ij, so again it will be 0. Now again ay into by, and there is j and j, that means this term is not 0 because j into j is 1, so I'll write this term, and all other term will be 0, only the multiplication of like term will be there. So a dot b is ax bx plus ay by plus az bz. Other terms will become 0 because of this thing. So now let's calculate the dot product of these two vectors. So now I'll consider this vector to be a and this vector to be b. Now I'll find the cross product. So in cross product we have to multiply only like terms. So 11 into 4 plus 11 into 2 plus 15 into minus 3. For other terms we'll get 0, so we are not writing other terms. So we'll just multiply only the like terms. So now when you solve this, you'll get 21. So out here you can see we are multiplying two vector, and this side we are not getting I, j and k. That means we are getting just a pure number, that is a scalar quantity. So now next question, we have to find the angle between A and B. So using this formula I can find the angle. So I have to find this theta. So for that I have to find A dot B and magnitude of A and magnitude of B. So A dot B is 7 into 6 plus 4 into minus 2 plus minus 4 into 3. So you will get 22. Now magnitude of A and magnitude of B, that is 9 and 7. Now I'll use this formula. Now cos theta is A dot B by AB. Now I'll put the values, that is 22 by 7 into 9, and cos theta is 22 by 63, and theta is equal to cos inverse 22 by 63. So this is the final answer. So the angle between A and B is cos inverse 22 by 63. Suppose A dot B is 0. Now let's find what is the angle between A and B. So this is the formula. A dot B is AB cos theta. If you put A dot B is equal to 0, then you will get AB cos theta is equal to 0, and if you take this AB down there, you will get cos theta is equal to 0, because 0 by AB is 0. Now theta is equal to cos inverse 0, and cos 90 degree is 0. That means cos inverse 0 is 90 degree. So if A dot B is 0, then A and B are perpendicular to each other, because the theta is coming to be 90. Let's find the angle between these two vectors. So suppose this vector is A and this vector is B, then A dot B is 2 into 4 plus 4 into 2 plus 4 into minus 4. So this is 8 plus 8 minus 16, this is 0. So we got A dot B is equal to 0. So we can directly write as A dot B is equal to 0, then A and B are perpendicular to each other. That means angle is 90 degree. Now you can try this question. A vector is given by 9, 5, 4. That means you have to put I, j and k. So A vector will be 9i plus 5j minus 4k. So this way you can solve this question. Out here magnitude of A and magnitude of B is given and angle is given. So you have to find A dot B. So from 1 to 3 you have to find A dot B. And in second question you have to find the angle between A and B. Again you have to use 2i plus j plus 3k, and for this question you have to find the value of alpha when these two vectors are perpendicular to each other, and we know when they are perpendicular A dot B is 0. So you find A dot B, then you equate it with 0, then you can find alpha easily. So this is the end of the video. Please don't forget to like the video.